An ice cube with a mass of 50 grams at -10 degrees Celsius is added to a large quantity of water at 0 degrees Celsius. Find the maximum mass of water that freezes into ice. In these systems, there are two objects that exchange the heat. One is the ice cube, another one is the water. Initial temperature of the ice cube is -10 degrees C, and initial temperature of the water is 0 degrees C. That means the water has higher temperature compared to the ice cube. So the net heat flow is happen from the water to the ice cube. Due to the exchange of the heat between the ice cube and the water, basically ice cube absorb the heat and the water release the heat. As a result, the ice cube's temperature will increase, and water, which is initially at 0 degrees C and with a large quantity of it, its temperature will maintain at the 0 degrees C, but some of the water will freeze into ice. That means when this system achieves the thermal equilibrium, all the ice cube, its temperature will be at 0 degrees C, and the water also at 0 degrees C, but some of the water will freeze into ice. To find the mass of the water that freezes into ice, we can start from these equations, where it says that the total amount of heat that gained by the ice cube is the same as the total amount of heat that is lost by the water. Now, to write down this equation, actually we already make an assumption where the heat exchange is only happens between the ice cube and the water. There is no any heat loss to the surrounding. The Qg for the ice cube is equal to MI/Ci delta T, and for the QL for the water is MWLF, where the Mi is the mass of the ice, Ci is the specific heat capacity of the ice, delta T is the temperature change for the ice. And the MW is the mass of the water that freezes into ice. It is not the total mass of the ice, which is not given in the questions, but it is referred to those part of the mass of those part of the water that freeze into ice. And LF is a specific latent heat of the fusion. Okay, although the process that happens is freezing, not the melting, but in calculating the QL, we still using the LF because the value will be the same for freezing and for melting. The LF is the same. Since we want to find the mass of the water that freezes into ice, which is the MW, so mathematically we change the MW as a subject of this of the equations. So we get MW equal to MICI delta T over LF. Basically, is we move the LF to the left hand side, but in writing we write the MW, which is the subject, at the left hand side. Also, we have these expressions. Now we can substitute value for the Mi, mass of the ice cube, which is 50 grams. And Ci is the specific heat capacity, which is 2100 kg per joule per kg per Kelvin. And the change of the temperature is we should take 0 minus -10, which is higher temperature minus the lowest temperature. Lower temperature. 0 is the temperature when the system change when the system achieves the thermal equilibrium, which is 0, and it is the final temperature also for the ice cube. So we take 0 minus -10, and then divided by LF, which is a constant, which is 3. The value is 3.36 times 10 to the power 5. As a result, we have the MW equal to 3.13 times 10 to the power -3 kg, or 3.13 gram. Now, please take note that this MW that we obtain is not the entire waters that that is in the system. Only part of the water, due to the heat loss to the ice cubes, will freeze. So the mass of the water that freeze into the ice, not the entire water, only part of the waters, the mass of those part of the water that freeze into ice is 3.13 gram.